Hey, good morning. How are you? Congratulations, first of all. And now you ask what I'm talking about. Congratulations to all of you as you reshaped the data analytics landscape. Can you imagine, back in the days when we started, I was involved in that conference since the very first edition. And back then, Hadoop was a challenger that was trying, that with promising the capabilities and scalability, that's something that every company couldn't even maybe dream of, couldn't imagine that it was possible at that time. A special thanks to all of you that maintain, contribute to open source project that we all use. We very much thank you for this, for your work, that you probably also spend your free time doing this. Very much thank you. We started our journey at ING Wholesale Banking more than 5 years ago, setting up our own platform based on Hadoop. We set up the ambitious goals, and we set up the platform based on some specific use cases. This is how we avoid the pitfalls of data lakes, or as you may call them, data swamps. Basically, only having the passive approach, waiting for the data to appear, waiting for the use cases. We already have some final products that we wanted to deliver with that platform. That's something that very much helped us to creating a successful platform. We took a journey that probably most of you did so far. So we are we already experienced the benefits of Hadoop and Spark, especially comparing to the open source, comparing to enterprise data warehouses. We set up on a journey with these technologies, but we also seen that there are some major pitfalls coming with Hadoop. I'm talking to those of you that see the problem with, for example, packaging Python dependencies. I guess you all know that you have to maintain the specific Python package version for your specific models or for your specific use cases. So Hadoop is great, but here we've got some kind of a problem. We also see the race or hype, as you may call it, of public cloud, also the hype of managed services. So we would like to maintain, so we would like to consume the managed services. We don't like to maintain, to spend our time on daily operational tasks. We would like to break that connection with our servers. So I'm talking to those of you, if you still remember your server names by heart, might be there is something that you're doing something wrong here. So this is like in the dock on that picture. So this is something you probably want to avoid. Constantly chasing the Hadoop releases, that's something that didn't help us. That's something that we're really worried about. And if in the need, you are creating Apache yourself, you're creating a fork of a project, and this is a recipe for disaster. You can refer to some examples, even from high-tech companies, that they forked the project and they will remain with their very own version. That was cutting edge in the beginning, but now it's all legacy. Before we start jumping into the technology, it's something that I would like to stress out. After almost a year working on that platform with the original idea that started almost a year ago, that you should really ask yourself constantly, why are you doing this? Why are you taking this or another approach? I know we are fan of technology. We are jumping very quickly into the new stuff. But what I wanted to propose is like user-centric architecture. So you should put your user in the center of your thinking. Okay, it sounds cliche, but to make it more tangible for you, at ING, we would like, as a special unit at ING, we would like to free the data. We would like to make the data available to our users to make it more so our clients can benefit from that. The data should flow with the users. The users should be free to choose their own tools, and we should guide them on that tool. We should be showing them the surroundings, not selling them a package holidays, so they cannot, pick up any new stuff, so they cannot choose any more options in the package. So that's the way. This is how we build our architecture. We are focused on our users, what they really need. We constantly ask our users whether these are data scientists that they hate platform people, because usually we deliver something that does not meet their criteria. So we constantly ask them, what do you need? What would be great for you to make your work easier? Okay, back in the day, like less than a year ago, when we started that journey, that we also pretty much quickly standardized around microservices architecture. So there's a rise of microservices. We also decided to standardize around containers. That help us to create a unified layer to package our dependencies. And also, this is one of the major things that we believe it makes us cloud agnostic. This is the highest level of abstraction that is common across different clouds or on-premise. You can run it anywhere nowadays. And basically, I believe this is the slide that all of you were waiting for. We are technical people, so what the guys come up with. But you know, when I was talking with what I was talking already, I guess it's no surprise for you. There are some things that you need to have a storage. Yeah, with all the things that, yeah, we love HDFS, we love Hadoop, but there's a problem with that technology if you go into the containerized world. There's a new project that creates object storage on top of HDFS, but we decided we would like to go a different route. So there's a storage layer, there's a unified compute layer that allows you to run different workloads, and not only specific, not tied to YARN, that allows you to run your microservices application and also run your computation on that platform. For users, they've got a front-end layer. They've got a single entry point to the platform, which is a portal that helps them navigate through different parts of our system. Asking our users, user-centric architecture, if you ask data scientists what they would like to work with, Jupyter notebooks, that's something that they like, that they want. That's the next Excels of the data analytics nowadays. They've got it. For BI users that are fan of SQL, as you know, it's like nowadays 80% of analytics is done by Jupyter. It's done by SQL, basically. It's a secure environment. We give our users a secure desktop environment. That's the Guacamole logo over there. With the power of community, we set up on Kubernetes. Just to refer to the power of community from the beginning of my talk. If you take the latest KubeCon conference from December, it gathered 8,000 participants, which is year-to-year growth of 80%. So you see the power of community and where the people are going nowadays. We are talking about enterprise environment, so we need to integrate with the rest of the organization. But we see it is possible using open source tools. As you see with Apache Atlas or Apache Render, you are able to integrate with the rest of enterprise organization. You can think of Apache Atlas like not a very sexy term of data governance, but we believe we can use that technology also to support data quality needs. So we do data quality assurance needs. So we can capture metrics over there. We can see that we can gather all the metadata around the data that can help further analysis. We'll cover some of these points later during this presentation, but let's start with the unified storage. Basically, what we aimed to do with the new platform, what we see would be required for us, is to have a single storage layer that can cover all our needs. That means the place where we can store data, object storage, with the familiar S3 interface. So we are, remember, being cloud ready, cloud agnostic. We've got also a raw block device storage, so we're able to support persistency for the containerized workload. What the very thing that was missing here, this is not public cloud. We were missing a unified identity and access management layer. That's how Airlock was born. This is our solution to create a unified authorization layer on the top of our platform. It communicates with Ranger, it's checking the policies, but it's also giving us short-term access services. So we are able to grant our users access for a limited period of time. So for example, we can give our analytics access only for 8 hours, so they can see what's inside the data, but the access is revoked immediately. This is our open source project. We will very much encourage you to check this out, to contribute, or just simply see what we are up to. Your turn.
Thank you, Chris. Okay, hello and good morning. Okay, so I'll take over on some more of the challenges and things that we've done inside our data analytics platform. Firstly, Kubernetes is at the core of pretty much everything we do here. And we use Kubernetes as our container orchestration framework. And by that, I mean we use it for all the typical use cases for Kubernetes. We take stateless microservices and we deploy them onto our cluster. We monitor their load, and we auto-scale them to keep our service at the levels we like. And that's great. That meets a big chunk of our use case. However, as Chris mentioned, we actually want to run absolutely everything we do as a container. This allows us to be both cloud-ready and also cloud-agnostic. So containers are the sort of generic building block of the cloud. By running everything in containers, we are cloud ready. The problem here is by running everything in containers, we are running things like big data workloads, multi-petabyte big data workloads like Spark inside containers. And this presents a whole new type of challenge. So while a typical Kubernetes workload is not that elastic, it will scale just slightly based on load, big data workloads want to take all available spare compute resource, finish their calculations as quickly as possible, and then scale back down, freeing up the cluster for other analytics workloads. And by default, Kubernetes is not really designed around that usage pattern. So we have to extend Kubernetes with two non-default bits of functionality. The first thing we used is a piece of software from OpenShift, which is a layer around Kubernetes, which is called a multi-project quota. And this allows us to pool those idle resources so that we can say, while this project may only have access to 5% of our overall cluster, if it's doing a Spark workload, we can give it short-term access to 90% of everything we have, which is terabytes of memory and thousands of cores. So those big data workloads are super quick. This, however, could present a challenge, because if we're running a big data workload on our cluster and we need to run a much more important microservice, we might find the latency of our cluster becomes terrible as we wait for resources to free up. So then we also enable a second feature, which was released as a beta in Kubernetes 1.11. It's still not stable yet, which is the pod Priority and Preemption. And this allows us to take these big data workloads, flag them as lower priority, and then more important workloads can essentially kick them off the cluster to make sure we're always ready to spin up user services on demand without big data interrupting this. And we find with those two primitives, we are essentially able to support both microservices and streaming data alongside dynamic big data workloads, all within the same framework, which is excellent. Okay. So while we are an analytics platform, we're really a data science platform at heart. Our whole department was built around the meeting of AI and big data. And therefore, we have a lot of data scientists, and we appreciate that they're both a very scarce and very valuable resource. And we found in our old platform that they actually spent a significant proportion of their daily job not doing data science. They were doing software infrastructure, creating their environments. They were doing data engineering to get the data they need to actually start doing modeling. So we made it an additional goal of this platform to try and speed up this process and keep them focused on what they do best, which is data science. So to this end, we created something called Data Science in a Box at the core of this platform. And what this is, in essence, is a UI that enables a data scientist to spin up an isolated secure container containing JupyterLab. And within that, they can bake in all their dependencies, all the models they require, and it will just be built and deployed onto the cluster ready for them. Within this environment, they also have immediate access to all the data that they are allowed to see. So they don't have to go around looking around the organization for the data they want to model. It's just presented right there to them. And finally, we also add in additional tooling that they can call on demand. We want them to always use the best tool for the job. Python and SQL is not always the best. So there is a TensorFlow cluster ready on demand that gets deployed again to our Kubernetes cluster. If they want to run a TensorFlow job, they can just call out from their notebook and run that. They can also run things like Druid, Presto, or Spark jobs on demand from inside this environment. Okay. So the data analytics platform, we don't want it to be thought of as just infrastructure or a collection of tools. We want it to really be thought of a user-centric platform as a service. And that requires a portal to make it user-friendly and to straight away get a user into the two things they require, the tooling and the data that they want to use in conjunction with that tooling. So we built this, the Dap Portal. And the first thing you see when you log into our platform is the service catalog. It shows you all the tools that you're able to see. And top of that list is a SQL interface in Apache Superset. So a basic data analyst can just log in and straight away access all the data with SQL. Okay, behind the scenes, we're all big data snobs here, so that's actually using the Facebook Presto engine, and it's able to scan 5 billion transactions a second, which is quite fun, but to all intents and purposes, it looks like an environment that our users are already very familiar with. The second part is the data portal, the data discovery component. This is interesting. This is actually an open source product called Munson. We're co-creating this with Lyft in the USA. And this is what you see here behind me. So it is a search-based interface for finding all the data that you want. If I want to do customer analysis, I can run a search and find out what the ING data source is for customers. That speeds up getting new data scientists into the company and working quickly. It also introduces a social aspect to the right. So we actually allow you to follow other colleagues and see what the power users in your department are doing. So again, to help get you up to speed, and you can follow the people who are already doing their jobs well. Okay, so within a bank, security, I think, is actually the single biggest challenge we've had building the data analytics platform. And it's basically because we're building the conflicting goals of bringing cutting-edge big data technology into one of the most regulated industries on Earth. And this has some obvious challenges. So an example being open source projects tend to have security as a bit of an afterthought. It's not the sexiest area of development. It's not the most interesting. So security features often get bolted on later in development. And you'll find this even enabling things like SSL in some big data projects, you'll find is actually quite problematic. I, however, think the most interesting challenge here is what I call the problem of proliferation. If you want to build a small data platform, let's say 3 tools, let's pick Spark, Flink, and Kafka. As soon as you start thinking about all the supporting infrastructure you need, the different back-end databases, the different authorization systems, the different configuration management systems, that rapidly becomes 10, 15 systems. This is an architectural nightmare. It's a support issue, but also it's a security challenge because you need to understand all those frameworks. You need to have them all penetration tested. And for things like authorization, if you've got 3 tools telling you what your users are allowed to do, are you sure they're actually consistent? Do you really know what someone can access? So building Dap, the thing it's taught me is my new favorite number is 1. I want 1 tool for every concern. And that is not a simple task. That requires work. So to give examples, again, authorization, we've selected Ranger. It's an excellent authorization tool, well built into Hadoop. And we have taken that and built layers to allow that to integrate with all the other data accessing tools we have, such as Chris mentioned before, the airlock tool, so we can unify that with our S3 storage. Another example is authorization. So lots of open source tools use different standards, Kerberos, OpenID. We settled on OpenID for everything, and we've written layers to enable us to just focus on one technology. Good. So banking is a highly secure industry, as mentioned, just because of the confidentiality and the sensitivity of the data that we're given. And security is more than just platform security, whether you can be hacked or not. It's also data security. What this means in reality is we need to know at any point in time where our data is. If data needs to be deleted, updated, created, we don't just have to go to the source system. We have to find it in all the data scientists' separate data marts. We need to go and tidy that up. And that can only be met with something like data lineage. So every time we transform data, we move it somewhere else, we need to track that. And data governance is pretty much close to non-existing in the big data space. In lots of proprietary software, you get this out the box. It does not exist in many big data tools. There is, however, one shining star here, which is Apache Atlas, which is a tool for tracking lineage, for storing it, and for visualizing it. And again, with our rule of 1, we want to bring that into all the tools that are able to write data. We find that in conjunction with Ranger, this is actually very powerful, because if I set permissions on the source system, I can then cascade those permissions down by following the lineage in Atlas, and I can therefore not have to set rules on every small data set we make from the source systems. I can just cascade those rules down. This does, however, require quite a significant development effort on our part, because it's up to the actual data tool you're using to send the lineage to Atlas. It's not fetched by Atlas. So we've been working on things like Apache Spark to build Atlas plugins, and we'll be working with other frameworks in future. Okay, so we've covered quite a few of the significant challenges you have bringing cutting-edge big data tools into a large organization. And what do you need to successfully be able to do this? Well, firstly, you just need a world-class team. It's not a simple challenge. And I've marked where the members of our team come from on a map, and a world-class team is, by definition, an international team. It actually personally really annoys me that I can't say we've got all continents. So if you've flown in from Antarctica or North America, please talk to me after the talk. A world-class team is a couple of things. It's very much embedded into the world of open source. We're not just taking these big data tools and deploying them. We're always having to write integrations. We're always having to modify the original projects. And we never want to branch these tools because we'll just swap one maintenance challenge with another. We'll just build the legacy of the future. So all our developers have to be well-versed in the world of open source. They have to be able to make the kind of pull requests that get accepted and be able to push them through. The team members also must be multidisciplinary, because to deliver a platform like this, we need development, we need operations, we need front-end, back-end. We also need more unusual disciplines like non-financial risk or ethical hackers. So we really have quite a wide range of skills in this team. We do have a stand outside. If you're interested in working on the team, please talk to us later. I'd also give a quick shout out to the conference organisers, Get In Data. We actually have 3 of their members working on this currently on the data science in a box component, and they've been delivering some really, really great work so far. So finally, I'd just like to say thank you all for listening to our talk. I hope it at least sets your mind in the kind of things you need to think about when bringing exciting big data technology, actually bringing that to an organization and making it work in the real world and in practice. So thank you, everyone. Thank you.